Hello students, how are you? I hope you are doing well. Today I am again with another video. This time I have picked questions from uh, Gravitation and SHM. These questions were asked on the morning session of 25th January 2023 JEE Mains. So let us discuss the first question. As you can see, T is the time period of simple pendulum on the Earth's surface. Its time period becomes xt when taken to a height r equal to Earth's radius above the Earth's surface, the value of s. In other words, we have to find the factor of change for the time period of simple pendulum. Factor of change for the time period of simple pendulum. Now, time period of a simple pendulum, it is given by this. Now, when it is taken to a certain altitude, what happens is the value of g changes there, and accordingly period of oscillation or the time period will change. As we know that at high altitudes the value of g reduces as compared to that on the earth's surface. The value of g at a height h is given by the value of g on the earth's surface into this distance. I'll take it as r, and this distance as capital R. So this is capital R by small r whole square. Okay, where small r is capital R plus h. This we have to remember formula. So on the Earth's surface it is 2 pi under root L by G naught given, whereas here at a certain height h, the value of t, I'll take it as t dash, is 2 pi under root L upon G. Is it? So if I divide equation 1 by 2, I have t dash by t is equal to under root, sorry, g naught by g. And from here, g naught by g is small r by capital R whole square. In other words, t dash is equal to small r by capital R into t. So as per the question, small r is capital R plus r, because height is capital R given in the question. It's taken to a height r. So the new time period is 2r upon r into t. So x is 2. Then moving on to the next question. Assume that the Earth is a solid sphere of uniform density and a tunnel is dug along its diameter throughout the Earth. It is found that when a particle is released in this tunnel, it executes SHM. The mass of the particle is 100 gram, time period of the motion of the particle. Now, students, this is of course a hypothetical question, but if we assume that things could be like that, then we don't have any problem. Uh, when a particle is released in a so-called tunnel, which is dug along the Earth's diameter, not even diameter, it can be along any chord also for that matter, and it will execute SHM. The only requirement is that the particle should be released from any point on the tunnel. It should not be thrown with any initial velocity. I'll derive the formula and then we'll discuss certain interesting facts regarding this. So this is the Earth, and you have a tunnel done. Let us say P is the instantaneous position of the particle at a distance x from the center O. Remember, this center of the Earth becomes the mean position during the course of simple harmonic motion. So let us say this is the distance. Then here acceleration will be the consequence of gravitational pull of the Earth on the particle. Mass of the particle I have taken as n. So acceleration will be in the negative x direction. This will be force acting on the particle upon its mass. Now force acting on the particle, you know it is G capital M small m by R cube into x. You have to remember this problem, students. I hope most of you might be knowing this. Within the within the Earth's surface, the gravitational pull is given by this formula, where x is the distance of the point from the center. So this m gets cancelled, and we are left with this a equal to minus gm by r square into 1 by r into x. Because gm by r square is capital G, m by r square is small g, that is acceleration due to gravity on the Earth's surface. You must remember this. So I'll write this as g upon r into x. This is the standard form of a particle executing SHM. Any particle executes SHM if its acceleration is directly proportional to x and is directed towards the mean position. In the standard format, it is like this, where omega is under root g by r, and we all know that the period of oscillation is given by 2 pi by omega, which is equal to 2 pi under root r by g. Okay, if you substitute r equal to 6400 kilometer and acceleration due to gravity as 10, then you will get somewhere around 1 hour 24 minutes. You have to remember this, 1 hour 24 minutes. So correct option is first option. One small information, students, we come across two more situations where the time is same, and both the situations are related to Earth. The first situation where you come across the same time is the period of revolution of an artificial satellite revolving close to the Earth's surface. Again, I'll repeat. It is also equal to the period of revolution of an artificial satellite revolving close to the Earth's surface. Same time, that is 1 hour 24 minutes approximately. And another situation is this time is also equal to the time period or period of oscillation of a long, infinitely long simple pendulum oscillating above the Earth's surface. That is, if you take a long pendulum, infinitely long pendulum, and if you make the bob oscillate above the Earth's surface, then the time period will be same as this 1 hour 24 minutes. So you have to remember these things. Moving on to the next question. The distance between two consecutive points with phase difference of 60 degree in a wave of frequency, this is this velocity with which. Now we all know that wave velocity is equal to frequency into wavelength. Frequency is already given as 500 hertz. Hertz means per second. Now wavelength we have to calculate. In order to calculate wavelength, what information they have given? Two consecutive points are there which differ in phase by 60 degree. We all know that if we have 2 points A and B which are separated by one wavelength, then they differ in phase by 360 degrees or 2 pi radian, isn't it? and the phase difference is proportional to the separation between the particles within one wavelength, of course. Within one wavelength, the phase difference between two particles will be proportional to their separation between each other. So, what we can do is the separation of 6 meter induces a phase difference of 60 degree between the particles. So, naturally, in order to have 360 degree phase difference, the separation can be calculated. So, 360 degree is to lambda equal to 60 degree is to 6 meters. So lambda is 36 meters. So substituting the value of lambda, we have this 500 can be written as 1000 by 2. So 1000 by 2, 218. So this is 18 into 1000 meter per second, and 1000 can be replaced by the SI prefix kilo. So 18 kilometers per second. So correct answer is 18. Sorry, 18 kilometers. That's all in this video, students. Thank you so much.